In this module, we're going to look at some of the ideas of fluid statics. And in this video, I'm going to introduce fluid statics and the reasons why we're interested in. Just as you would expect, fluid statics is looking at the forces on fluids that are static. That is, they're not moving. So there are still lots of interesting cases where we have fluids that exert forces, even though the inertial forces, those associated with velocity, are pretty small. Simplest example might be if we've dammed a river like this so that we've got water backed up behind the dam. It's not moving very much, even if maybe we have a little pipe coming out here that's allowing some water to pour out. It's not moving very much, so we can treat it as if it's static. And by looking at that, we can figure out what the pressure forces are that are acting on this dam that would tend to push it over like this. We'd like to avoid having our dam burst, so we need to know about the forces exerted by the pressure. In order to know about the forces exerted by the pressure, we need to be able to figure out what that pressure actually is at different locations in the fluid. Now, if we consider this case, and we consider, for example, a swimming pool, a very deep swimming pool, but not nearly as big as the reservoir behind the dam, we could ask ourselves the question, is the pressure at location 1 significantly different from the pressure at location 2? So I'd like you to pause for a moment and ask yourself, do you think those two pressures are the same or different, and why? How about this case where the walls aren't vertical, where we're concentrating our reservoir down onto a small area? Water there, and we've got this small area down here. What about location 3? Is the pressure there different from the pressure at locations 1 and 2? If you're like a lot of people, you probably want to say that the pressure at location 3 will be higher than the pressure at location 2. You might also want to argue that the pressure at location 1 is greater than the pressure at location 2. And you might get to that by an intuitive sense that it has to be higher because you've got all of this mass up here pushing down on this one little area. But you would turn out not to be right. Let's think about it for a moment. Yes, the pressure is the result of the fluid up above pressing down on the fluid that's down below here. But in these cases where we have a whole lot of fluid, either here or here, and a small area there or there, we also have this fluid being supported by forces from all around. So in addition to the pressure forces pushing up on the bottom like that, there are also pressure forces acting perpendicular to the surface all the way around this reservoir. The result is we aren't supporting all of this weight on that small area. We're supporting it spread over the entire area of the reservoir. Likewise, we aren't supporting all of the weight of the water behind this wall on just the area of the wall. We're also supporting a bunch of it on this part of the reservoir back here. So even if we made this reservoir much bigger, with a whole lot more weight of water behind it, we still wouldn't increase the pressure acting on this wall. So now we have some ideas about what we'd like to know. We've got a way of thinking about pressure. We know that on any surface, the pressure will act perpendicular to the surface against the fluid on the one side. And we have some tools that we've developed in the previous modules to look at how those forces interact with each other. And they're going to be much simpler if we can make the assumption that U is equal to 0, that our fluid is static.